IPMAT 2024 short answer question. Let f and g be two functions defined by f of x is mod of x plus mod x, g of x is 1 by x for x not equal to 0. Fine. And I also given f of a plus g of f of a is 13 by 6. Then the maximum possible value of f of g of a is what? Let us first understand what these two functions mean. G of x is easy to understand, right? It's given g of x is equal to 1 upon x. So that's just the reciprocal of the number. So whatever function, whatever number I put, the reciprocal of that number is g. So obviously x cannot be 0. The interesting thing is this. It says f of x is mod value of x plus mod of x. Now, modulus means the positive and the negative value of the number always become positive. So that means two possible scenarios. If the original number itself is positive, then f of x is x plus mod x is nothing but x. So this is 2x and x is positive, 2x is positive. But what if x is negative? Then in this case, I get f of x is equal to x is a negative number. Let's assume minus x plus modulus of minus x. So that becomes minus x plus positive x. So these cancel out each other, ends up as 0. So f of x is a very interesting function. If for a positive number, f of x is 2x, right? So let's put it like this, that f of x is equal to 2x if x is greater than or equal to 0, doesn't matter. And if f of x is 0 for values x less than or equal to 0, the equal can come on any side, doesn't make a difference, right? So that's how I newly define the value of f of x. And g of x I for sure know is the inverse of the function. Okay. So now I have to take into consideration what has already been given to me, which says that f of a plus g of f of a is equal to 13 by 6. Alright. So two cases where if a is positive, it's a different function, and if a is negative, different value. Let's take positive. So for positive, a f of a is 2a. So this becomes 2a plus g of 2a is equal to 13 by 6, and g of any number is the inverse. So 2a plus 1 upon 2a is equal to 13 by 6. So I get 4a square plus 1 upon 2a is equal to 13 by 6. So 24a square plus 6 is equal to 26a. I can reduce it by 2. So 12a square plus 3 is equal to 13a. So 12a square minus 13a plus 3 is equal to 0. So 12a square minus 9a minus 4a plus 3 is equal to 0. So 3a into 4a minus 3 minus 1 into 4a minus 3 is 0. So if a is positive, I get the value of a, 3a minus 1 is 0. So a is 1 upon 3, or 4a minus 3 is 0. So a is equal to 3 upon 4. I get two possible values of a in this case. Great. But what if x is negative, right? Do I need to go there? Well, let's see what happens if x is negative. Okay. In case x is negative, then f of a is 0. So this becomes 0 plus g of f of a is 0. But I know that x, the value of the number x cannot be 0. So g of 0 cannot be defined. So this second scenario is not going to exist, right? So a is not going to be a negative number. So I don't have to worry about that. So now I am left with only two possible values of a. Either a is 1 by 3 or 3 by 4. And I need the maximum possible value of f of g of a. So either it is f of g of 1 by 3 or it is f of g of 3 by 4. Great. So f of g of 1 by 3. G of 1 by 3 is 3. So this is f of 3. And f of a positive number is double the value of the number. So this is 6. F of g of 3 by 4 is going to be f of 4 by 3 because g of value is inverse, reciprocal. And f of 4 by 3, positive number, double it. So this is equal to 8 by 3, which is equal to be 2 point something. And I need the maximum possible value. So this is not my answer. So the maximum possible value in this case is going to be 6. That's the answer, hopefully, which should be the solution to this question.